Page 2 of skills test number 11 practice. Continuing with number 32, it asks you to find the degree and the types of roots and then the sign of the leading coefficient. All right, so let's head to the degree and count our directional changes. Here's one direction, and 2, 3, 4, 5, 6, 7. The degree is 7. Here's a single root, passes straight through it. There's only one, so one single root. Here's a double root, it bounces off. Here's a double root, so we have two double roots. Now, one single and two doubles, that adds to 5 of our degree that we need out of the 7. That means the remaining 2, since there aren't any more real ones, would be complex. And lastly, the leading coefficient, since our graph is heading upward, okay, it's headed to infinity as you go to the right, then the leading coefficient, let's just abbreviate that, LC, is positive. Okay, over here we got one direction, two direction, three direction, 4, 5, 6, 7. The degree is 7 again. We got one real root right there. It's passing straight through it, so one single root. That means the remaining 6 would be complex. And lastly, our leading coefficient, since this graph is headed downward as it heads to infinity, it's headed to negative infinity, that would be negative. All right, changing gears, some polynomial division here, some long division. So let's head to our generic rectangle tool. Binomial goes down the left side. First term goes inside the top left box. And this is how we start our problem every time. The value that we put here times 2x has to equal 6x to the 4th. So it's going to be a 3 to get us a 6. And it's going to be an x cubed to get that x to the 4th power. And then once we insert that number, we multiply it by what's down here, this negative 1, and it goes inside the box here, negative 3x to the 3rd. And now we ask ourselves, what would have to go in this box so that when you add these like terms together, you get this? So this would have to be 8x to the 3rd. Now when you add those two together, you get that term. Once you figure out what goes in this box, you start this process all over again. This value right here, this term multiplied by 2x would give us 8x to the 3rd, so it has to be a 4, and it has to have x squared. 4x squared times this negative 1 goes in this box down here, negative 4x squared. And now, next column, these diagonals have to add to 4x squared. So we would need positive 8x squared here so that they do add to 4x squared. This would be a 4 to get the 8. 4 times 2 is 8, and x times x would get us the x squared. 4x times negative 1 is negative 4x. Another set of diagonals. These diagonals here have to add to 6x, so we're looking at a 10x in this box. 5 times 2x would get us 10x, and 5 times negative 1 is negative 5. We are at the remainder stage. These guys right here need to add to negative 3, and the value that we put here is our remainder, which would in this case be 2. Those add to negative 3. So the remainder gets placed at the end of our expression here. So we're going to write what's across the top, 3x to the 3rd, 4x squared, 4x, and 5. I had to insert plus signs in front of all those since they were positive. The remainder is 2, so that requires another positive, since it's a positive 2, which you place on top of the binomial that you had out front. Okay. B, x minus 2 or x plus 2 down the side. First term is x to the 5th power inside the top left box, and we begin. This would have to be x to the 4th power. Those two multiplied together is x to the 5th. X to the 4th times 2 is 2x4. These diagonals have to add to the x to the 4th term, and there isn't an x to the 4th term, so they need to add to 0, x to the 4th, which means we need negative 2x to the 4th in order for them to add to zeros, x to the 4th. All right, so we got negative 2 to get this negative 2, and we would need x cubed to get that x to the 4th power there. Negative 4x to the 3rd for multiplying these two. Our new set of diagonals have to add to negative 2x cubed, which means we need positive 2x cubed here in order for that to work. Here we get a 2x squared to get this 2x cubed and 4x squared down below. Our next set of diagonals has to add to 3x squared, so we need a negative 1x squared, which would give us negative x up above, negative 2x down below. Our next set of diagonals needs to add to x, which means I need 3x here. So we put a 3 up top and a 6 down below, and the next number I write is the remainder. These two need to add to negative 1, so we're looking at negative 7 in order to get those to add to negative 1. So the expression I have going across the top of my generic rectangle is part of my solution here. And then the remainder, since it's negative, I write a minus sign, and 7 goes on top of the binomial we pulled out front. Okay. So that's some polynomial division. Hopefully that jogged your memory. Now let's head to some 3 equations with 3 unknowns problems. Let's see. Try to anticipate what's going to be easiest to combine. If you look at the numbers that are in front of the y's, those are awful. And there's no way I want to try to eliminate y's. When you got a plain x like this isn't a bad thing to do. I could turn that into a negative 5 so that the x's cancel. I could also turn that into a negative 4 so that those x's cancel. That's certainly one route. If I look here later, I see I've got this minus z. The fact that it's already an opposite sign, I like that. That's my favorite right there. So I'm going to choose to get rid of the z's in my first step here. So in order to add this middle row to the top row and have the z's cancel, I need this to be negative 2z. I'm going to multiply this entire row by 2 and just write it right here to the side. And now I'm going to add the top to my new middle equation. Add those together. And that's going to create an equation that doesn't have any z's in it. I got 7 x's. I have negative 2 y's and negative 20. No more z's. All right, now I need to combine 2 other equations. I could choose to do the top to the bottom or the middle to the bottom. Those are my 2 options, and the middle to the bottom is definitely the route to go. Except I need this number here to be negative 3 so that it will cancel with that positive 3. So I'm going to multiply the entire middle row by 3. 3x minus 15y minus 3z equals negative 63. So now when I add that to that bottom row, adding these 2 together, I'm going to get another equation that doesn't have z in it. I'm going to put it right underneath this first equation we got. So I have 7x, negative 9y, and negative 41. All right, 2 equations, 2 unknowns. You've been doing that for years. If I were taking a look at this, I would want, the x's to cancel, rather than turning these 2 numbers here into 18s. I'm going to change these 7s into 1 being negative. In fact, I'll choose the bottom one to be negative. That way, that'll give me a positive 9 right there. So if I multiply this entire row by negative 1, I get negative 7x, positive 9y, and positive 41. So when I add these 2 equations together now, x's cancel. I have 7 y's and 21. And that's a good sign because we're all about to know what y is going to equal. Y is going to equal 3 when you divide. So there's one of our answers. And 3 has to be plugged back into one of these equations, maybe this top one there. So 7x minus 6 equals negative 20. If you let that y be 3, that's what you'd get. 7x equals negative 14. If you add 6 to both sides, then x ends up being negative 2. And then take those two, go back to one of these originals. I'll use the bottom one for no good reason, because all those values are positive, I guess would be the reason. So negative 8 plus 18 plus 3z equals 22. That's 10, which you have to store to the other side by subtracting 10. So 22 is going to turn into 12. Z is going to end up being 4. And it does say find the point of intersection. So these three values would be expected to write as a three-dimensional coordinate point where x goes first, y goes second, and z goes third. And that's that coordinate point. All right, I'm going to stop right there, and I'll do 34B on the next video. Took a little long. I'll see you in a little bit.